Welcome to a journey that transcends the boundaries of time, a journey into the past and the future, a journey into the realm of time travel. From the earliest myths and legends to the most cutting-edge scientific theories, the concept of time travel has ignited the human imagination like few other ideas. It's a universal fascination, a topic that has intrigued minds across cultures, generations, and disciplines. It's a notion that has stirred us to question the very fabric of our existence, the nature of time and space, and the endless possibilities they hold. Time travel, in essence, is a journey. It's a voyage beyond the confines of the present, a leap into the depths of the past or the heights of the future. It's the dream of revisiting bygone eras, of witnessing history firsthand, or peering into the unknown realms of what's yet to come. It's the allure of altering our destinies, of righting past wrongs or preempting future ones. But time travel is more than just a flight of fancy. It's a subject of rigorous scientific inquiry, a field where fiction bleeds into theory and theory into potential reality. It's a world where Einstein's theory of relativity meets the fanciful narratives of Back to the Future and Doctor Who. It's a domain fraught with paradoxes that challenge our understanding of the universe and our place within it. In this video, we'll journey through the multifaceted world of time travel. We'll explore its portrayal in pop culture, its basis in scientific theory, and the paradoxes it presents. We'll delve into the latest research, the ethical implications, and even theories that venture beyond the realm of physics. We'll unearth the intrigue of time travel, the enigma that has captivated storytellers and scientists alike for centuries. We'll dissect the myths, the theories, the debates, and the discoveries that surround this tantalizing topic. So buckle up as we delve into the mystery and allure of time travel. Time travel has captured our imaginations through numerous narratives in popular culture. It's a concept that has intrigued us for centuries, sparking countless stories and theories that continue to captivate us. These narratives, while largely fictional, have shaped our understanding and expectations of time travel. Let's begin our journey through the world of pop culture with a classic, H.G. Wells' The Time Machine. Published in 1895, this novel introduced us to the concept of a vehicle that could transport its operator to different points in time. Here, time was treated as a fourth dimension, a concept that was quite revolutionary and ahead of its time. Wells's vision has since become a staple in time travel narratives, providing a blueprint for many stories that followed. Next, let's hop into the DeLorean and travel back to the future. This iconic trilogy, which began in 1985, presents time travel in a light-hearted and entertaining way, albeit with its fair share of dramatic twists. Back to the Future popularized the idea of time as a mutable continuum, where actions in the past can drastically alter the present. It also introduced us to the concept of time paradoxes, which we'll delve into later. From a time-traveling car, let's switch to a time-traveling police box. Doctor Who, the long-running British TV series, features the adventures of the Doctor, a time-traveling alien with the ability to regenerate into a new form when fatally injured. The show's concept of time travel is fluid and often whimsical, with the Doctor's TARDIS able to transport him to any point in time and space. Doctor Who has provided us with a multitude of time travel scenarios, from historical events to distant futures on alien worlds. Now, let's take a quick detour to the world of comics. The Flash, a superhero from DC Comics, has the ability to travel through time using his super speed. This introduces the concept of time travel through physical exertion or manipulation of one's own abilities, a theme often explored in superhero narratives. On a darker note, the Terminator franchise offers a grim perspective on time travel. Here, it's a tool used to prevent or ensure a dystopian future ruled by machines. This narrative presents a deterministic view of time, suggesting that certain events are destined to occur, regardless of attempts to change them. In literature, A Sound of Thunder by Ray Bradbury introduced the concept of the butterfly effect, where minor changes in the past can drastically affect the future. This short story has had a profound impact on time travel narratives, highlighting the potential consequences of meddling with history. In the realm of anime, Steins Gate presents a complex and intricate exploration of time travel, using the concept of diverging timelines. It's a mind-bending narrative that delves into the psychological effects of time travel, a theme often overlooked in traditional narratives. These narratives, and many others, have shaped our cultural understanding of time travel. They've introduced us to a plethora of concepts, from time machines and paradoxes to multiverse theories and the butterfly effect. While these stories vary greatly in their approach to time travel, they all share common themes: the allure of exploring different eras, the desire to change the past or future, and the unintended consequences that come with it. However, it's important to remember that these narratives are works of fiction crafted for entertainment and intrigue. They often bend or ignore the laws of physics to suit their narratives, creating scenarios that are currently beyond our scientific reach. But that's part of their charm. They allow us to explore the concept of time travel in a creative and imaginative way, sparking our curiosity and inspiring countless debates and discussions. These narratives, while largely fictional, have shaped our understanding and expectations of time travel. They've made us question the nature of time, the flow of events, and the possibilities of what could be. They've allowed us to dream, to wonder, and to imagine a world where time is not a linear path, but a vast landscape waiting to be explored. So, the next time you watch Marty McFly race against the clock, or the Doctor step out of the TARDIS into a new adventure, remember that you're not just enjoying a good story. You're participating in a long-standing cultural fascination with time travel, a concept that continues to captivate us, from the pages of science fiction novels to the farthest reaches of theoretical physics. And who knows, maybe one day we'll uncover the secrets of time travel, turning these fictional narratives into reality. But until then, we'll continue to explore this fascinating concept through the lens of pop culture, where the possibilities are as boundless as time itself. These narratives, while largely fictional, have shaped our understanding and expectations of time travel. They've made us question the nature of time, the flow of events, and the possibilities of what could be. They've allowed us to dream, to wonder, and to imagine a world where time is not a linear path, but a vast landscape waiting to be explored. Now let's venture into the realm of science and explore the theories that underpin the concept of time travel. Time travel isn't just an intriguing idea spun out of the loom of the science fiction genre. The science behind it is equally captivating, albeit complex. First, let's delve into the concept of wormholes. These are theoretical structures in space-time, often depicted as a tunnel with two ends, each at separate points in space-time. In simple terms, imagine folding a piece of paper, representing the fabric of space-time, and then punching a hole through the two layers, thus creating a shortcut. This is the essence of a wormhole. In the context of time travel, a wormhole could potentially allow an object to traverse vast distances of space and time instantaneously, or at least significantly faster than would be possible through conventional means. However, it's worth noting that wormholes are purely theoretical at this point. Their existence has not been confirmed, and the idea of using them for time travel remains firmly in the realms of speculation and hypothesis. Now let's shift our focus to a concept that's a bit more grounded in established science: Einstein's theory of relativity. This theory fundamentally changed our understanding of physics, and it has some fascinating implications for time travel. The theory of relativity consists of two parts: special relativity and general relativity. Special relativity, proposed by Einstein in 1905, introduced the idea that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is the same, no matter the speed at which the observer is traveling. This leads us to the concept of time dilation. Time dilation is a difference in elapsed time measured by two observers, due to a relative velocity between them or to a difference in gravitational potential between their locations. To put it in layman's terms, time can slow down or speed up depending on how fast you're moving or how strong the gravitational field is around you. This has been observed and confirmed in numerous experiments. For example, atomic clocks flown in jets or placed in high-altitude locations have been found to run slightly slower than those at sea level, due to the effects of both speed and gravity on time. General relativity, which Einstein proposed about a decade after special relativity, extends this framework to include gravity as a curvature of space-time caused by mass and energy. In the context of time travel, general relativity allows for the possibility of wormholes and other exotic structures in space-time, although it also suggests that these might be inherently unstable. So if you were to travel near the speed of light or near a massive object, according to Einstein's theory, time would run slower for you relative to someone who is stationary or far away from the massive object. This is essentially a form of time travel into the future. However, traveling back in time is a much thornier issue and is generally considered to be impossible under the current understanding of physics. The concept of time travel is not merely a product of wild imagination, but it's deeply rooted in theoretical physics. The theories of wormholes and time dilation provide a scientific perspective to the possibilities of time travel. However, it's crucial to remember that our understanding of these theories is continually evolving, and they are subject to revision as new data and insights emerge. While these theories might seem complex, they provide a fascinating scientific perspective on the possibilities of time travel. As we continue to push the boundaries of our understanding, who knows what we might discover? Perhaps one day, the realm of science fiction and reality might not be so distinct after all. Time travel isn't without its paradoxes, adding yet another layer of complexity to this concept. When we envision hopping into our time machines and zipping into the past or future, we often overlook the logical conundrums that this leap might entail. Let's dive into some of the most famous paradoxes that have perplexed both scientists and enthusiasts alike. First up, we have the grandfather paradox. Imagine if you could travel back in time and meet your grandfather when he was a little boy, long before your parents were born. What if, in a tragic twist of fate, you accidentally caused his demise? Without your grandfather, your parents, and subsequently, you could never have been born. But if you were never born, how could you have traveled back in time to cause your grandfather's death? This paradox raises a significant contradiction. If you can alter the past, you might erase the cause of the time travel itself. Next in line is the bootstrap paradox, also known as a causal loop. This paradox is a little more mind-bending. Imagine you're a scientist who invents a groundbreaking piece of technology. One day, a stranger from the future appears and hands you a blueprint for the very technology you invented. You realize that the blueprint is identical to your design. As it turns out, this stranger is you from the future. You copied the design from the blueprint and built the device. But here's the paradox. If the blueprint came from the future and you copied it, who actually invented the technology? This paradox suggests that information or objects can exist without any discernible origin. The butterfly effect is another fascinating paradox, although it falls more into the realm of chaos theory. The term originates from the idea that the flapping of a butterfly's wings in Brazil could set off a tornado in Texas. Applying this to time travel, the paradox suggests that any minor change made in the past could drastically alter the course of history. If you traveled back in time and merely stepped on a bug, you could potentially change the entire ecosystem, leading to a drastically different present. This paradox emphasizes the potentially catastrophic consequences of meddling with the past. Then we have the predestination paradox. Imagine you receive a mysterious letter from the future detailing an impending disaster. Determined to prevent it, you build a time machine and travel back in time to send the letter to your past self. Now, the paradox here is that the disaster was always meant to happen, and your actions merely ensured that the cycle continues. This paradox suggests that events are predetermined and that even time travel can't alter them. Lastly, let's consider the quantum superposition paradox, which brings quantum mechanics into the mix. According to this paradox, a time traveler could exist in a superposition of states, much like Schrödinger's cat being simultaneously alive and dead until observed. If you traveled back in time and changed something until you returned and observed the present, the outcome would exist in multiple states. This paradox challenges our understanding of reality itself. These paradoxes provide a captivating glimpse into the logical conundrums and contradictions that time travel presents. They force us to question our understanding of causality, reality, and the flow of time. While these paradoxes might seem to discourage the possibility of time travel, they are, in fact, a testament to the complexity and intricacy of the concept. As we learn more about the universe and the nature of time itself, who knows, we might one day unravel these paradoxes and fully comprehend the enigma of time travel. These paradoxes challenge our understanding of time and reality, Adding to the enigma of time travel, scientific research has also ventured into the realm of time travel. While the concept remains largely theoretical, some intriguing experiments have offered glimpses into the potential mechanics of traversing the temporal dimension. One of the most intriguing areas of research involves subatomic particles, particularly a type known as neutrinos. These minuscule particles, billions of which pass through us every second, have been observed to demonstrate peculiar behavior that seems to defy our conventional understanding of time. Some experiments have suggested that neutrinos can oscillate between different types, a phenomenon that, according to the laws of quantum mechanics, implies they are in multiple states at once until observed. While this doesn't constitute time travel in the traditional sense, it does challenge our linear perception of time and suggests that at the quantum level, the rules may be different. On a more macroscopic scale, we have the fascinating case of time dilation experienced by astronauts. This real-life phenomenon is a direct consequence of Einstein's theory of general relativity. According to the theory, gravity can bend space-time, and a strong gravitational field can slow down time. To put it simply, time moves slower the closer you are to a massive object. This has been confirmed by precise experiments. Astronauts living aboard the International Space Station, for instance, orbit Earth at such high speeds that when they return from missions, they are technically a fraction of a second younger than they would have been if they had remained on Earth. In 2017, a team of researchers made headlines when they used one of the world's most accurate atomic clocks to confirm this effect. The team placed one atomic clock at sea level and another high up on a mountain. After letting the clocks run for a few months, they found that, as predicted by Einstein's theory, the clock at sea level closer to the Earth, and thus in a stronger gravitational field, had run slightly slower than the one on the mountain. While this is not time travel into the future or past as we often imagine it, it is a form of time shift. It's a reminder that time as we know it is not an absolute, but rather a relative and mutable aspect of our universe. Another area of research focuses on the concept of wormholes. These theoretical passages through space-time are solutions to the equations of general relativity and have long been suggested as a possible mechanism for time travel. However, creating or finding a stable wormhole, not to mention figuring out how to traverse one, remains a significant challenge. In 2015, scientists made a breakthrough by creating a magnetic wormhole, an invisible tunnel that transferred a magnetic field from one point in space to another. Although this was a magnetic wormhole, not a gravitational one that could transport matter and information, it's a step toward understanding how these theoretical tunnels might work. It's important to note that all these experiments and theories, while fascinating, do not provide definitive proof of the possibility of time travel. They do, however, expand our understanding of the universe and time's place within it. They remind us that time, as we experience it, is part of a much larger, more complex fabric of reality. As our knowledge expands, so does our understanding of what might be possible. The science of today would have seemed like magic to the scholars of the past. Who knows what the science of tomorrow might reveal? These studies, while not conclusive, add a tangible dimension to the otherwise abstract concept of time travel. Time travel isn't just about science and fiction. It also raises profound ethical and philosophical questions. So, let's dive into the moral maze that is time travel. This journey will take us through the realms of free will, causality, and the potential consequences of altering the past. Firstly, if we could travel back in time, would we still have free will? Or would our actions be predetermined, since the past has already occurred? This conundrum challenges our fundamental understanding of freedom and autonomy. If our actions in the past are preordained, then we are merely actors following a script, our free will an illusion. But if we do have free will in the past, then we could potentially change the course of history. This brings us to the second point: causality. Causality is the relationship between cause and effect. In our everyday lives, the cause always precedes the effect. But in time travel, this could be reversed. You could theoretically go back in time and cause an event that has already happened. This reversal of causality is known as retrocausality, and it's a mind-bending concept to grapple with. Let's consider the implications of this. Suppose you went back in time and prevented your own birth. This is the well-known grandfather paradox. If you were never born, then you could not have gone back in time to prevent your birth. So you would be born after all, which means you could go back in time and prevent your birth, and so on. This paradox highlights the logical contradictions inherent in time travel, and it's a major headache for philosophers and scientists alike. Now let's explore the potential consequences of altering the past. If you could change the past, even in the smallest way, it could have a ripple effect on the future. This is known as the butterfly effect, a term borrowed from chaos theory. According to this theory, a butterfly flapping its wings in Brazil can cause a tornado in Texas. Similarly, a minor change in the past could lead to major changes in the future. So, if you could go back in time, should you intervene in the past? Should you prevent a tragedy or let history take its course? These are not just hypothetical questions, they are deeply ethical ones, and they force us to consider the potential consequences of our actions. For instance, if you could prevent a war, would you do it? On the surface, the answer seems obvious, but consider this. Preventing a war could alter the course of history in unpredictable ways. It could lead to an even worse conflict, or it could prevent important social and technological advancements. The future is a complex web of interrelated events, and tinkering with it could have unforeseen consequences. Moreover, if we could travel through time, who should have this power? Should it be available to everyone or only to a select few? And who decides who those few are? The potential for misuse is immense. Time travel could be used to rewrite history for nefarious purposes, to erase mistakes, or to gain an unfair advantage. These considerations raise important questions about justice, power, and responsibility. In conclusion, the ethics of time travel is a complex and multifaceted issue. It challenges our understanding of free will and causality, and forces us to consider the potential consequences of altering the past. These considerations remind us of the profound implications and responsibilities that would accompany the power to travel through time. So, while the allure of time travel is undeniable, it's important to remember that with great power comes great responsibility. Time travel theories aren't limited to the realm of physics. In our journey through the corridors of time, we've ventured into the realms of science fiction, wrestled with paradoxes, and even delved into the fabric of reality itself. But what if the key to time travel isn't nestled within the equations of quantum mechanics or hidden in the folds of space-time? What if it's locked away in the most complex structure in the known universe, the human mind? This concept may seem more at home in a philosophical discourse or a metaphysical exploration, but it's not entirely estranged from the world of science. Consciousness, the awareness and perception of one's surroundings and inner thought, our minds. Beyond consciousness, let's take a detour into the realm of parallel universes. The multiverse theory, a favorite among science fiction writers, suggests the existence of an infinite number of universes, each with its own version of reality. In this grand cosmic theater, every decision we make could spawn a new universe, a new reality where a different choice was made. If the multiverse theory holds water, time travel might take on a whole new dimension. Perhaps the past and future aren't points on a linear timeline, but rather separate universes existing concurrently with our own. Traveling through time could then be akin to shifting between these parallel realities. But what does this mean for our moment that time doesn't flow like a river or tick away like a clock? Instead, it exists as a vast frozen landscape where the past, present, and future coexist. This is the concept of the block universe, a perspective that suggests every moment in time exists simultaneously, and it's our consciousness that navigates through this temporal landscape, creating the illusion of time's passage. In this view, time travel wouldn't involve jumping into a DeLorean or stepping into a TARDIS. Instead, it would require a shift in consciousness, a way to navigate through the block universe and perceive different moments of time. These theories, while unconventional and far from proven, expand our understanding of time travel beyond the confines of physics and into the vast expanse of the human mind and the very nature of reality itself. They invite us to question our perception of time and challenge us to consider the possibility that time travel might not be a physical journey, but a metaphysical one. And while these theories may seem abstract, even fantastical, they remind us that the exploration of time travel is not just a quest for scientific understanding, but also a journey into the depths of human consciousness and the mysteries of existence. These theories challenge our conventional understanding of time and reality, opening up new possibilities and perspectives on time travel. Time travel, a concept that has intrigued us for generations, remains an enigma. We've journeyed through the captivating narratives of popular culture, where time machines and paradoxes abound. Stories like Back to the Future and Doctor Who have not only entertained us, but also shaped our perception of what time travel could look like. We delved into the realm of hard science, exploring the theoretical constructs that might make time travel possible. The concept of wormholes, the intricacies of Einstein's theory of relativity, and the fascinating phenomenon of time dilation have given us a glimpse into the complex world of physics that governs the fabric of time. We navigated the tricky paradoxical waters, grappling with the grandfather paradox and the butterfly effect. These paradoxes, while bewildering, underscore the inherent logical contradictions and challenges that come with the idea of traveling through time. We looked at the cutting-edge scientific research and experiments probing the boundaries of our understanding of time. From studies involving subatomic particles to the impact of time dilation on astronauts in space, the quest to unravel the mysteries of time is ongoing. We also pondered the ethical and philosophical implications of time travel. Questions of free will, causality, and the potential consequences of altering the past brought us face to face with the profound moral dimensions of time travel. We ventured beyond the confines of traditional physics, considering unconventional theories related to consciousness, parallel universes, and the nature of time itself. These theories, while speculative, compel us to broaden our perspectives and question our fundamental understanding of time. So here we stand, at the crossroads of science, philosophy, and imagination, contemplating the enigma that is time travel. As we wrap up, remember that the journey doesn't end here. As we continue to explore and understand this mystery, remember, time travel isn't merely about moving through time, it's about understanding the fundamental nature of time itself.